looks like this function right here, or relation, I should say, is as a graph. It's a hyperbola that's been rotated. Here's my work for finding y prime. I did factor a minus sign out of the numerator and then reverse the order of these two terms by factoring out a minus 1. And that's how I got rid of this minus sign here. This f of xy matches what I have right here. And f of 1 comma 2 is 7/2. And if I write the equation of the line that passes through the point 1, 2, which appears to be on the curve, with a slope of 7/2, I do get what looks to be a tangent line to that curve. And if you'll notice it appears that as we move from left to right from the point 1, 2, the tangent lines are decreasing in slope, which means that at the point 1, 2, the curve looks like it's concave downward. And so we would expect the second derivative at the point 1, 2 to be negative. So if we go to the next board, g of xy is where I applied y double prime. I found y double prime from this definition of the first derivative. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, 2y prime minus 2, all over the denominator squared. Now at this point, you don't have to try to solve for, well, you've got y double prime, but you don't have to try to simplify it, is my point. You can just plug in the 1 for x and 2 for y and 7/2 for y prime. And I think you'll see that it does simplify to negative 17/4. So take a snapshot of the formula for y double prime, see if you can match what I did. In other words, it looks like this: 2 times 2 minus 2 times 1 for x, etc. And you should get negative 17/2. Negative 17/4, which tells you that at the point 1, 2, the curve is concave down. So there you go. Hope that helped.